Hey, good morning. I said it'd be a few weeks before I did another video, but I thought I'd take the opportunity to come in here and show you exactly what I have planned. I've actually been ordering the few remaining parts that I needed to finish this whole thing up, and um, I did get the new spray cap in for the RF deck. And the spacer for this, I just put the screw in for now. The spacer for this, I found a round spacer for M4 size screws, and these are 8/32 this cap took. So it's, it's the same size M4. It's a little bit bigger, slightly I think it's like what, there's something, it's like a less than a tenth difference or something. It's so tiny. So, but I found some round spacers. I found one that's going to fit right in here, and I'm going to be able to tighten it up, and it'll be perfect, and I'll have that new cap. And those spacers are supposed to be here sometime late this afternoon or this evening, I believe. I found them on Amazon. They're aluminum, and they're for M4 screws, but oh no, I take that back. They're not from Amazon. They're from they're from an online supply place. But they're supposed to be here today. If not, they'll be here tomorrow. So as soon as I get that done, I'm going to flip this thing over. If I don't get it today, then I'll just flip it over and I'll start on this. But what I'm going to do is I decided I'm going to change out this relay. There's an extra pole on this, and I don't like this relay. The contacts, the wipers are really thin strips, and all three of them are really close together. And it's too many. It's an extra pole that I don't need. This is like a triple pole double throw, and I need just a double pole double throw. So I found some of these new old stock manufacturer NTEs, just like the one I have on the exciter rack. So I'm going to wire that up. So I'm going to have all matched relays. So what I'm going to do is the one I have on the exciter, this is just interchangeable. I can plug one of these in, so I'm going to do that. I'm going to put one of them here on the RF deck to replace the one under there, and then I'm going to put this one on the final modulator rack for the 810 bias shift between transmit and receive, or transmit and idle. So I had to order some tools. These are, this is what I'm doing. And now that I've got my shop, that I'm putting all my shop together, I've got to get tools too. And there's so much stuff that I don't have. Like nowadays, everybody's using these metric the M2 through M5 6 screws. This is a whole set, M2 through M5, the nuts and everything, washers and different size screws. It's an assortment. And this is a whole just 8/32. And of course, I'm buying nothing but stainless steel hardware. Stainless steel is the only way to go. So I don't have the tools for this, but luckily I found an Allen wrench in my, one of my tool shells, and I found it, so I was able to do it. So I'm leaving that in there. This is all 8/32 only. So I got that kit, and I got the stainless steel washers for them too. The lock washers. So I can get some of the star ones too, and I'm going to get those next. Those are kind of hard to find, but I came across them. I just got to find the website where I found them. But these are the nut drivers for the the M2 through M5 button head assortment, and then these are the ones for the nuts, right? And there's an M6 in this too, and these shafts slide up and down on these. These are basically what these are for. These are like for remote controlled, like RC controlled cars and planes, and these are the tools that they use for those. But here nowadays, I'm trying to find hardware, because a lot of stuff nowadays, it's all coming from China, and everything now is getting to be metric. So I like the kind with the Allen head. I like the button head screws, machine screws with the Allen heads, for those drivers. It's easier, Phillips screwdrivers, man, those things, you strip out the heads, and as long as you make sure these things are inserted all the way in the button head and all the way down in there, you don't strip them. These things are they're so much better, What I need is I need to get a real expensive set of the ones that got the T-handle, the rubber T-handle you can interchange, or some of them just have the T-handles, but I don't need all that, man. I just need enough to get me going here and get started on everything again, like I did back in the old days. And what you use nowadays for hardware is not the same as what we used back in the day. Things have changed a little bit. So anyway, so that's the status. I got the relays. So I'm going to change out this relay And I'm going to go ahead and I'm also going to start on the putting this bracket on here, this L bracket. I'm going to mark and cut this probably by tomorrow. I took that capacitor off and I'm going to figure out exactly where I'm going to put it, how high it needs to be. I am going to cut it off. I'll just mark it and I'll see if I can't hacksaw it off and if I can file it. If I can't get the first one to look right, I have 9 more in the box. It was a pack of 10 for like $6. So I thought, hey, I got plenty to get it right? I'll just keep doing it until I get it right, make it look nice. So anyway, that's the story on that. And then I'll take it in there and I'm going to test it back out to make sure everything's switching. Now, one thing I'm thinking of doing is these relays will key faster if you run them, say, like at 13 volts instead of 12 volts, and it won't hurt those coils. They'll handle an extra volt easy, even 2, but you know, an extra volt will make these things key a lot faster. And see, I've got this supply in here, and the way I had to do it was I had to leave the center tap of the transformer floating. I used a bridge and a voltage regulator to get 12 volts. But then I have that diode in series, you know, with the negative lead when I key to isolate all the supplies from each other, you know. So that drops down 0.7 of a volt, at least 0.6, right? So 0.6 or 0.7 on average. So that's going to be what, like around 11.3 volts on this relay. Now see, that's below 12. It'll key all the way down to like around 10 volts, even down below that. But still, the lower the voltage is, the slower it is at keying. So I think, you know, I'm thinking about maybe grounding. I need to see what this transformer is. Maybe if I make it full wave center tap grounded, the voltage may be too low, and it may. But who knows? I'd have to see it. I'd have to try it to see. But I just need to see. First of all, I cannot read this. I need to get a light in here. I think this is a 60306 6.3. I mean 6.3 volts, 6.3 volts 0. So if you ground it, yeah, it won't work, I don't think. So I had to just go from end to end and leave the center tap grounded and use a bridge. But I'm wondering if I could just get rid of that regulator to get the voltage up. And then, but it's, you know, I may just leave it like it is, and I may just leave the one, because I'm doing the exact same thing on the RF exciter. So that relay's sitting at about 11.3 volts on the coil. So I'm thinking, do I want to get those up? And what I should do is, I think the ones on my plate supplies are running way too hot. I think they're still like around 14 volts. I did add a diode, so that would have dropped it down to like a little over 13, like 13.7, 13.8 or something. I don't know. Let's see. But I was going to check that supply in there, and I was going to decrease the voltage of those plate relays, because that means those are going to come up faster than these other ones, and it'd be better if they were the last thing to come up. So I am going to decrease the voltage on those. What I can do is, if I have to, I can just add another series diode in there on the 12 volt line going to those 2 relays. That's all I got to do. You just add a diode in there and it just drops it down, and may have to add 2, you know. One more diode probably, if it's still too hot. You have to measure across the coils, not from ground, because you got the diode in there. So you got to go across the relay coil itself and see what it is. Because right now this one's like it's under 12. It's like 11.3 or something like that, right? So that's typical, right? Because the voltage drop of the diode has to be factored in. So that's how you can get the voltage on your relays, right? Just add series diodes till you drop it down where it needs to be, or get it close enough. Then you got to figure out another way to add a series resistor to get it the rest of the way to limit the current, and do it that way. So that's what I'm doing. So anyway, let's get on to this. And what I was going to get into was that what I'm going to do to the modulator. But first, let me show you too. Let me show you the circuit again here, if you can see all of this. And I don't know if everybody got it good. Let me pull up. Last time, a lot of people weren't getting that I have 200 volt supply going into this. And I'm going to get to that here in a minute. And what I figured out was, yeah, when this thing's just at idle, when you're not transmitting, this, say 500, whatever, I was getting like just under 400 volts here on this thing when it's not transmitting, which is a little high. But I'm just going to go with it for right now. Then I'll see if I have to drop the voltage down. Because if I drop it on one side, it'll go down on the other automatically too. And what I mean is here on the primary side. So I went through, well, if you go through both these, you know, on my actual setup, I don't actually have two 12Ks. I have one of these is larger than the other one. I don't remember which one I put where. So, but when I go through it with both of them in parallel, the 6K. So I thought, okay, now I just want to I just want to try to get the voltage about the same here on the primary, because remember I told you it's way higher than this side, and they should be exactly the same. So if I put a 6K there, that should get it somewhere close, you would think, right? Because this is going through this diode, and okay, just all right, that should be all right, right? I mean, it should be the same thing. So that should be the equivalent circuit. Now on this, you've actually got the modulation going down through this thing. It's actually hitting this soft limit resistor. Here on this side, there is no modulation. It's just a center tap, you know, because I have a 16 mic cap going to the high V supply that's going into here, right? And I probably should put a cap right here on this side of the diode. I'm probably going to put one here to ground and here to ground just to kind of protect things. It probably wouldn't hurt, you know, but it's just this is only here. So when this thing is at idle, this has got the voltage goes through the both, so it's on both sides of the windings, both the primary and secondary side of this is the modulation transformer, right? And so then when the high V gets turned on, well, it gets blocked, and that whatever voltage is here, it's just sitting there until when this thing gets released, what happens is this voltage slowly comes back up on both sides, because it's that keep alive voltage, but it has to be on both sides. And that's what I wasn't recognizing, because I have two separate plate supplies. Most people have a common high V plate supply for the modulator and the RF deck, right? It's the same. Not all the time. People have, there are setups out there where people do have separate supplies like I do, especially if they're running the modulator tubes up at a higher voltage for a specific reason, to compensate for, you know, maybe they've got modulator tubes that aren't quite powerful enough, so they run them a little bit hotter voltage to compensate, right? A lot of people do that, and that's just one of the reasons they do it. But most of the time, it's a common supply. So after I thought about it, it made perfect sense, you know, right? Duh. And when the plate supply lets off the secondary and the primary, you want that keep alive supply voltage to still be there. So when those two supplies when they let off and they drop down and they start bleeding off real quick, they're still sitting there at that keep alive supply level on both sides. That's the whole idea. So that's good. Anyway, let me see here. Now, so you can see what I was going to do here, the minus 200 volts. Now, on my speech amp driver, and you got to remember, my speech amp driver is the small rack that's mounted vertically, but right now it has the 6A3 tubes on it. And the final the final AF modulator, the final modulator deck with the modulation transformer here and the 810 tubes and etc. The driver transformer and the bias supply for it, they're all on that deck. The bias, what I have is, I have this transformer. It's the Johnson desk. This is a Peter Dahl special that I had him do years ago. It was a replacement for the one in the desk kilowatt. And it's 150 volt center tap at 150 mils continuous. And that's at 100 with the older, little bit lighter input primary voltage. So they're going to be a little hotter than 150. And what I have is, I have the center tap grounded, of course, and then I have it in there where I have the 810 grids. Currently, they're both shorted together. There's actually two separate windings, but I have them together that go into the grids, and I have a common supply. Technically, you're supposed to do them separately, which is what I'm about to do anyway. So what I'm going to do is, I have a 5R4 regulator, so I'm thinking what I'm going to try, I think this voltage, even though this is only 150 volt center tap, and if you ground this, it's going to be less than that, right? It's going to be half. I think it's still really hot. If not, what I'm going to have to do is I'll just unground the center tap, and I'll take 4 diodes and I'll make a bridge. I've got 3 amp diodes, I'll just make a bridge, right? And that's what I'm going to do. Then I'll have the 150 volts, but, you know, I mean, those are 3 amp windings, right? I'm sorry. What am I'm actually getting ahead of myself. I was talking about this one, but I got ahead of myself here. I was talking about what I'm going to do for the power of the relay. What I'm going to do is I can get the minus 200 volt supply from this is what I'm getting at. This input, where is it here? Let me show you my my updated speech amp driver circuit. And this is what I'm going to do. I'm going to use the 6AS7G tubes, and I have several sets of these new RCAs never used, new old stock. And they're the same as 6A3s, same as 6B4Gs, same as 2A3s, right? They're 6 volt, 6.3 volt filaments, but one tube is like two 6A3s or two 6B4Gs. I only have to use one tube. And here I'm adding an extra tube. Well, yeah, I'm adding an extra tube in my circuit. So my power transformer, the current was just big enough to power my existing tubes, but because I'm only going to have one of these 6AS7s, it's a twin triode. It's two tubes in one. I'm going to have one tube, so I'll have half as less current draw from, because I'm removing one of those 6A3s, so then I can add the other 6J5 or whatever one. I'm adding this tube. This is going to take the place of the 6N7, which also has a common cathode. A common filament. So that's, it's going to be the equivalent. By doing what I'm going to do with the tubes I have in there now, I'm going to be able just to, pull those out and rearrange things. Right now, what I have in my speech amp driver rack now, the one that sits vertical that my mic plugs into, it's a 6SJ7 going to the 6N7 phase inverter, and it's directly resistor capacitor coupled right to the 6A3 grids. And, the direct coupling like that would be better, but that circuit always had distortion. I was going to have to try to improve it because the one side, the ground side, was distorted. It got squared off at higher levels, and it was a problem. So probably using the transformer here is going to be better anyway. I have this Hammond transformer, and it's the nickel plated job too. I think it's also one of the better quality ones they sell. So anyway, but I had that, and that's what I've been using, and those two 6A3s are dying trying to drive those 810 grids the way it's been. And I've got the exact driver transformer, like I've got the KW1 driver transformer, and they use 2A3s driving the 810 grids. So I've got, but it's still even using a transformer is not as good as what I'm about to do. There's problems using that damn transformer. So anyway, but this is the plan, and this is basically a voltage regulated buffer setup for the 810 grids, and it solves the problem. And it came from this Class B driver circuit, this article in QST magazine back in July of 1955 is when it was published. And I'll tell you a funny story. This guy, I did some research on him, W2 ZGU, John W. Campbell Jr. He was a well-known sci-fi writer, and I'm sure a lot of the old ham nerds from the 50s, I'm sure a lot of the old AM guys were sci-fi nerds, right? Some of you guys are still alive, and you guys were real nerds back then. You know who this guy was. And apparently sometime in the 50s, I think back, it was in the early, the mid, and especially the late 60s, I don't know whether he published something, but he's the one that did this, and he was also a ham. And I don't know kind of how to explain it. I'm not getting into politics here on videos on YouTube, but I'm just trying to describe what actually happened, which might have been one of the reasons why a lot of his work was never really pursued. He was a famous science fiction writer. Like I said, I'm sure a lot of the old guys know who he was. This guy's name right there, black and white. Whether he said stuff in public, it was his politics that got him into trouble. And this was like right around the mid to late 60s, I think, is when it all blew up in his face. And he got thrown in that same category as Barry Goldwater. And if you know what I mean by that, that's all I'm going to say. No, I'm not telling you, I'm just telling you of some facts that something happened and this guy his reputation got tarnished. And there may be some people still around that know exactly what I'm talking about, but he got ridiculed by the left big time. And it was one of those, it was the late 60s when it all boiled over, and it was a different time back then, right? So that's kind of what happened to the guy, something like that. And I don't know if he stopped publishing or what happened, how long he was still doing sci-fi books and whatever. He was doing a lot of sci-fi articles in magazines and stuff. Anyway, but that's the research I did on the guy. But what I'm getting at is why this mod never caught on is amazing, because this is the solution. This guy was a genius. This is the solution. You don't need a driver transformer, and you don't need 45, 50 watts to properly drive 810s, and this circuit eliminates all those other issues combined. I mean, this is like, why didn't more people do this? Did anybody ever do this? Is any ham still around that knows anybody who did this? Because this is brilliant. I mean, it's a regulated driver for 810s, and you don't even need any power to drive them. Because it keeps the voltage up, so you don't have to have the power. And a 6J5 at 5 watts is more than enough. So it's brilliant, and this is my plan. And the whole idea is that, like I said, on my speech amp driver rack, all I have to do, I can leave the 6SJ7 as is with just a couple modification. I'm going to add, I originally had 10 watt Zeners here, but I thought no, because my power transformer is probably maybe a little bit light to properly do what I need it to do. And if I have to in the end, I'll just swap out the power transformer. It's the ratings on the power transformer and the voltage specs and the current rating are the exact same ratings from out of the general purpose modulator circuit out of the William Orr handbook, the radio handbook from the late 50s. It's the general purpose modulators. I built that thing, for component per component. And then I made a couple minor changes to tailor it to my voice to make it work a little better, and that was it. But it's still the standard general purpose circuit. So what I'm going to do is I have the 6N7 currently where the 6SK socket is. So I'm going to rewire that socket and put the 6SK7 there. Then I'm just going to since I'm only going to have one 6A3 on the top position, I'm going to put the 6J5. So I'm going to change out the 6A3 sockets because I got to have the what are they, the 8-pin octals, right, for the tubes. So I'm going to plug those in, and then put those sockets in and place the ones that are in those. And then I'm going to wire the one up, where the my 6A3 is, where it is on top. It's going to be where the 6J5 is going to go. And then I'm going to have just the single 6SA7, which is the dual triode, right there where the bottom 6A3 was. So I don't have to drill any holes. I'll have to drill a couple holes to mount the driver transformer, but that's fine. And then on the final modulator rack, I'm going to be able to, add this other, where is it here? The rest of this circuit. And then where am I here? Where did I put it? Oh yeah, here it was, right here. So see, I'm going to have, what I figured out, I already have the rheostats I had in my RF deck at one point. These are 25K at what, like 50 watt or something like that? 30. Yeah, I can use two of these, both of these right there, those are 25Ks. I can use both of those, and I'm just taking the existing circuit where he's got 250Ks. There's no way I'm using 250K resistors with those things you slide up and down. The windings on a 250K are so fine that you wind up, those windings open up. Anybody familiar with the Johnson Viking, the screen dropping resistor connection for this 807 screens? You know how that winding tends to open up. Oh, that's what I'm talking about. I'm not about to do something stupid like Johnson did back in the day. But that was, a cheap way to make kits and everything, and that's what they did, even the factory assembled ones. But you know, that thing was a really durable, those were durable transmitters though. They really were. They just cheesed down on doing a crappy bias-supply design where you didn't really have enough current to keep the 807 screen voltage stable, and you know, because it caves, it just dies when you modulate that transmitter. What you got to do is put like a big 47 mic cap to ground at the screens of those tubes to stop it from happening. That's the solution. So anyway, but that's what I'm going to do. And then my plan was I was going to take out that 5R4 socket and put in the OC3 tube, which I have plenty of those tubes. So I was going to rewire that socket, but then I thought about it. Wait a minute. I have to add the relay, right? So on that final modulator rack, that gray rack where where my big modulation, this big modulation transformer is, like where it is, it's right here, right? It's this one. I'm giving the finger here, sorry. that was not on purpose. I just realized I was because I had my other two fingers holding the paper. So anyway, I caught that though. That wasn't on purpose. Oh, I guess I could let that slip sometime on purpose and people wouldn't be the wiser, would they? No, that was an accident. So anyway, let's see here. Yeah. So anyway, but that's what I'm going to do. And I think, but what I'm getting at is here, I forgot what I was going to say, and it dawned on me. Well, you know, one thing I could do with that 5R4 socket, instead of using it for the OC3, do I really want to use another tube regulator? You know, that one's going to be on. The whole thing is, this one's going to be on all the time. When I turn the transmitter power on and the filaments start warming the tubes up, this one's going to come on. And it's going to be on until I turn that transmitter off. So do I really want that one there? And I thought, well, I could put a solid state Zener there, one of the chassis mount ones, right? Stud mount ones. I could just do that instead, since that supply is going to have plenty of current, and then I could just plug the relay in that thing instead. So I'm debating, you know, do I want to drill another hole, which is what I was planning on doing to mount this other socket that I have for this, or do I want to just, you know, or do I want to just, instead of putting an OC3 tube, I'll just use it for the relay instead, use that hole for the relay socket. So I haven't made that decision yet. So I'm going to be working on this tonight, hopefully. As soon as I get that spacer, I'm going to flip this thing over. And if it doesn't come, then I'm going to flip it over and I'm going to start working on that relay change anyway. And I'll just wait till the other comes and I'll just flip it over when I'm done and put it on them. But I don't like that thing vibrating around. I could tighten the screw where it won't do that. It's not really going to hurt anything. I would prefer, I like finishing what I'm working on currently before I start on something else. At least I try to, and that's hard to do sometimes for a lot of us, isn't it? It's like you want to have 5 projects going at once, which I still, now I said I like to work on one thing at a time, but how many things did I open up and start on and I didn't finish that are sitting over there? So I just, you know, I guess I'm being hypocritical, but hey, what the hell? This project's more important. This is my main priority. I want to get this transmitter finished up. I'm not waiting until next fall and go ahead. Now I got time to finish up the transmitter and realize that there's something else wrong like I did this winter. That was a mistake, but the thing is, I wouldn't have had time to have done everything that I figured out and all the changes that were necessary anyway, and all the changes I've made to this thing were darn well worth it. So, but I hope that makes sense of what my plan is. I'm just going to, you know, retrofit. I'm just going to rewire the sockets and change out 2 of the sockets on my speech amp driver, and I'm going to configure it this way. And then on the final modulator rack where the 810s are, I'm going to try to mount this circuit here with the other resistors, and I'm also going to probably mount this diode here and that resistor right there by the mod transformer as well. So I'll probably do all this mod. It's going to be on the mod transformer side, because I have RCA cables that go down, and what I'm probably going to do is I have RCA jacks RCA cables that plug in the bottom of the screen. This rack is mounted vertical in there, right? And the RCA cables plug from there down to the the final modulator rack, that gray rack. I have RCA jacks on there. Then I have just wires going to the 810 grids underneath that panel, that rack, that gray rack, that steel rack. And I think what I'm going to do is I'm going to convert that to really like good low impedance, like maybe 150 ohm XLR cable wiring all the way from one to the other. And that'll probably improve things tremendously. So anyway, that's the plan on that. So let me wrap this up. This has been a 30-minute video. I apologize again. And I'm just trying to, you know, let you see what I was doing. I was gathering up all my parts, and I've got about 2 more parts coming, and I've got everything. So like I said, I'm ready to get started on this today anyway, at least on this part of it. I'm going to get this buttoned up, check it again, and we'll go from there. 73s for now.